guys, now we are going to study case C of partial fraction, and the denominator consists of irreducible quadratic factors and they are also non-repeated. So considering an example where we have x plus 1 over x minus 3 into x squared plus 9, here we see that x minus 3 is a non-repeated linear factor. However, this one, x squared plus 9, is a non-repeated quadratic factor. So first of all, we check if the fraction is a proper fraction, which it is. So we start solving this question as let x plus 1 over x minus 3 into x squared plus 9 equals, as we know, a over x minus 3 plus, we have to write here bx plus c over x squared plus 9, which is the non-repeated irreducible quadratic factor. We let this equation as equation number 1. So now we have to learn the logic behind why we are writing bx plus c over the quadratic factor. We already know that the numerator must be having a degree 1 less than the denominator. But the question arises that we can also write a constant above this quadratic factor, or a term involving x above this quadratic factor, or simply this term. So why we are going to write bx plus c? To explain this, I have considered these three fractions. All of these three are proper fractions. While finding the partial fractions, we never know what kind of partial fraction are we going to get. So we have to consider the maximum number of options that can be covered while assuming the partial fractions. Let's say we assume this type, in which we have a constant above the quadratic factor, and in actual our result consists of a term involving x power 1. We cannot find that one. Let's say we assume this type, in which we have ax over x squared plus 1, but the partial fraction consists of a constant term alongside this ax. In that case, we are not going to find the constant ever. And let's say the partial fraction is of the type a variable and a constant. So we have to write ax plus b. In this way, if the actual partial fraction consists of just a constant term, the coefficient of the variable would become 0. If it consists just the variable term, the constant would become 0. And if it consists both the constant and the variable term, both of them would be non-zero. So now moving on, same method, we multiply equation 1 by x minus 3 into x squared plus 9. We get x plus 1 equals a multiplied x squared plus 9 plus bx plus c whole multiplied by x minus 3. So we let this equation as equation number 2 since it will be helpful while finding the value of a by the zeros method. We further solve this equation for our ease as ax squared plus 9a plus bx squared minus 3bx plus cx minus 3c. We get x plus 1 equals now combining the terms involving x squared, we get x squared into a plus b plus x multiplied by c minus 3b plus the constant terms that are 9a minus 3c. Let this equation as equation number 3. So now we find the value of a by the method we already know, known as zeros method. For a, put the denominator of a equals to 0 in equation 2. We get 3 plus 1 equals a into 3 square plus 9 plus bx plus c, that will eventually multiply by 0 when we put x equals to 3. So we get 4 equals a into 9 plus 9. 4 equals a into 18, or we get the value of a 4 over 18, or we can say a is equal to 2 over 9. To find the values of b and c, we now compare coefficients of x squared and also compare the constants. Comparing the coefficient of x squared, we get 0 equals to a plus b, and while comparing the constants, we get 1 equals to 9a minus 3c. So here, putting the value of a, we get 2 over 9 plus b equals to 0, and we get b is equals to minus 2 over 9. And here we get 1 equals to 9 into 2 over 9 minus 3c, so we get 1 equals to 2 minus 3c, where 9 and 9 are cancelled. So now we get 1 minus 2 equals minus 3c, minus 3 equals minus 3c, and we get this value of c equals to 1. Now we are going to put the value of a, b, and c. So we get x plus 1 over x minus 3 into x squared plus 9 equals 2 over 9 divided by x minus 3 plus minus 2 by 9 x plus 1 over x squared plus 9. We can simplify it further as 2 over 9 into x minus 3 plus minus 2x plus 9 over 9 divided by x squared plus 9, or we can simply write it as 2 over 9 x minus 3 plus minus 2x plus 9 over 9 into x squared plus 9, which is our resultant partial fractions. Thank you.